So there were 4 of us getting this organized, and hope you enjoy it. There's a representation of Get-In Data and Google as well over here, and Get-In Data is inviting for a beer after this meetup later, so good time to get together still after this. But in terms of agenda, so I'll talk a bit about logistics. I'll just give a very brief overview of OpenLineage as well, because some of you might not be familiar with what it is about. And then Mary will talk about OpenLineage and Google Cloud Dataplex. We'll get an update on the Spark integration from Paweł, and Jakub will talk about Airflow integration for the Python operator. And then Paweł will close with some motivational speech, I hope, on how can you get involved with contributing to Spark OpenLineage. We will have a break in between for about 45 minutes. There will be refreshments. Some of you just passed by those. Also good time to mingle a bit. And we'll finish around 8:30, roughly 8:30. I want to give some overview of logistics, as I said. So for folks in the room here, in the case of an emergency, we turn left, turn right into the hallway where there's the bathrooms as well, and there are stairs to get downstairs as fast as possible. Don't use the lift in the case of fire. Some other points here, you have to wear your visitor badge at all times visibly. Yeah, very good. You can move around this event space here. It's all locked off the other areas. So there's also the bathroom if you turn left. And then on the right side, feel free to go there. There are refreshments outside if you want to grab some water. That's outside as well. You must not take any recordings that contain confidential information. None of what is shared here is confidential. There shouldn't be anything confidential. Oh, well, yeah, okay. Then we need to remove that. No, there's nothing confidential here. And you can take recordings or pictures outside if you like, but please ask first and do it under supervision. But I don't think there's anything interesting here, but you will see. We want to take some pictures of this event because OpenLineage would like to, I think, do a blog post or so and about the event and then share. So that will be done a bit later. And we are recording the presentation and we will publish most likely on YouTube. I think we'll try to use the OpenLineage channel. And then, as I said, Get-In Data is inviting for a beer later. So hopefully a few of you folks stay around for that as well. So what is OpenLineage about? For those who don't know, I will be super brief about this, because I assume that most of you know, but anyway. So OpenLineage provides this spec, most of all, to exchange lineage information between those systems that transform or move data to those systems that are interested in capturing lineage information and making it available to consumers. So on the upper side, you basically have those SQL engines, you have orchestration tools, etc. And at the bottom, you have tools like Atlan Data Catalog sort of tooling and others. And you also see Google's logo here. Since recently, we just started adopting OpenLineage as well. OpenLineage is very much focused, or has been until recently, very much focused on capturing operational data lineage. So lineage as it occurs. So there's some data processing happening, inputs read, outputs written, for example, that amounts for a lineage event that OpenLineage aims to capture. Recently, also OpenLineage community started to look at capturing static lineage or design time lineage with a different type of events so broadening basically the scope of OpenLineage itself. The data model is reasonably simple. So there's this run state update, the lineage event I mentioned before, that's emitted by the systems you saw at the top, the orchestration system, execution engines. And this event contains information about what was the job that was executed, the specific run of that job, and what were the inputs and outputs read and written by that specific run of that job. And there, it's actually nice that OpenLineage went with an extensible model from the start. There are facets that can be attached to all of those entities of the run event, run state update. And also the community is contributing more of those facets to capture additional information like column level lineage, maybe some additional information about data quality or whatever about the data sets. So that's just a brief tour of OpenLineage. I think we believe it's very useful to have this standard basically of exchanging lineage information, both for producers and consumers. And so we have invested into providing some compatibility with OpenLineage. And this looks like that at the moment. So on the right-hand side, you see GCP Dataplex. It's a tool with which you govern your data. So it has a data catalog component, but does a lot more than that. Lineage is a crucial part of this. And so we have built the integration with Dataproc Spark through the OpenLineage interface. And we are also going to launch support for Airflow managed in Cloud Composer for OpenLineage production of events. That's coming next year, I guess. If you want to get involved with OpenLineage, you can join on Slack, you can check out the website, and you can certainly contribute, and Paweł will talk more about that later. Are there any questions about this brief introduction? No? Okay. Mary, you go first. So Mary is going to talk about how we are making use of OpenLineage in the Dataproc Spark and Dataplex integration. Thank
you. Let me and start sharing. Okay, thank you, Jens, for introduction. I won't repeat it, so let's start right away. I'll introduce Dataplex Lineage as our product. Talk about how we support OpenLineage, how the integration went on the way, and what improvements we would like to propose to make to make it go smoother, like for the future us or for similar integrations. And we will have time for the questions in the end, but if something is unclear in the middle, I'll also watch for raised hands in between the sections. So here I have a formal definition from our documentation, but basically data lineage is a Dataplex solution for tracking and visualizing data movements, also known as lineage. And when you work with it from GCP, you mostly see similar graphs, maybe more complex. So here I loaded a dataset from BigQuery to my project, and then ran two pipelines on it, one in BigQuery, one in Dataproc, and saved the result to BigQuery. So, for example, if you notice that something in the last table doesn't look the way you expect, you can trace it back and see, oh, there are actually two processes writing to it. So maybe they override each other. You can see what data they're reading from, whether it is correct, and how it was loaded. And the same downstream. If you want to know how your data is used, you can you can see what is down the road. So for GCP products, we have native integrations. BigQuery, the Cloud Data Fusion, Cloud Composer, and Dataproc, which means you just need to enable Lineage API in your project, and it will be reported automatically. And for a custom integration, it should be reported via our API. So I'm going to briefly describe it. So how do we represent Lineage internally? For each definition of a data transformation process, typically a script, we have a process. And then each execution of this process is called a run. And within the run, there are concrete data transformations and their state. And those are called events, which contain links between sources and targets, so between data assets. And as an example, for Dataplex Spark, we have a job definition as a process. Then each execution of this process would be a run. And within this run, we have data transformations represented as events, and they contain links. So if you work with the graph, you see two tables, a link between them. And when you click it, you see what process produced these links, link, and the runs of this process, so the executions. Now, how does it work under the hood? So if you plan to integrate with data lineage without using OpenLineage format, you would have to define the mapping between your notion of data processing, so process, run, etc., to our data model, and then do all the transformations and wrap it within RPC call and report it. So that means that this whole integration is tightly coupled with GCP, because you would basically transform the information to our format. Now, with OpenLineage, it's a very similar picture, but instead of customer connectors here, we have OpenLineage connectors. So, for example, for Spark, you would install Spark listeners dependency, and this whole work of creating the message, emitting it, would be basically reusable. So you would get more flexibility between lineage consumers, hopefully towards Dataplex. And that is the way to integrate that was piloted by Dataproc. So Dataproc Spark, sorry. So they would report via OpenLineage. Now, what are we doing with OpenLineage messages on our side? For each job, we have a process, and job facets are represented as process attributes. And the same for the run. And then run event loosely maps to lineage event. And for inputs and outputs, we are creating a Cartesian product of those and create links. So I'll move to the challenges if there are no questions.
Do you accept OpenLineage events from like arbitrary connections targets? Is it an open API, or do you accept only from Spark?
It is an open API, but to see it on the UI, you would have to have the assets in Dataplex.
Okay, so I can't like just run OpenLineage link integration right now and have them. Okay.
But you would still be able to fetch it the same way via API, just not. Yes, sorry.
I've got other question. I'm Kuba. I work for Allegro, and we use OpenLineage for Spark running on Dataproc already. And I was wondering if you are able to change the consumer of OpenLineage events generated by the default data lineage API, because it is great that you can right now enable the data lineage API and simply generate the OpenLineage events. But we'd like to change the consumer of it to our, let's say, custom service on Cloudra, for example. Is it possible? Do you know?
I can return to you after the presentation. I don't know.
Maybe very small there. So you want to commit Spark OpenLineage events into Dataplex, for example, right? And you're asking whether that's possible.
No,
emit them from the Spark job on a Dataproc,
Yes.
but consume them on
Somewhere else.
Somewhere else.
Right. All right. Okay. Yes. Well, I think we need to check whether that's possible because you need to fiddle over a bit with the configuration of Dataplex.
Okay, I got it. And my question was because we add some additional URL params with metadata of the job, and we consume them later. And that's why we use custom service to consume those events. And that's all we need at the moment. So okay.
Okay. Thanks a lot for the input. So I'll move to the challenges that we faced during development, and as we mostly explored Spark, they will be related to Spark. So the first was rather an ambiguity than a huge challenge. But when we were defining the API endpoint, we had to basically listen to two sources of guidelines. One is Google-owned API improvement proposals, and the second one is OpenLineage format itself. So in most cases, it was straightforward what to follow. But when we were defining whether to process messages synchronously or asynchronously, there was a small conflict. So the AIP stated that if a method takes significant amount of time to complete, it should be asynchronous. At the same time, we saw that OpenLineage client already developed asynchronous. And after giving it a thought, we decided to go with synchronous mode, but also limited the message size to make sure we can kind of predict the time of the request completing.
Sure, okay. We can send them to Kafka, and I want to be able to configure Kafka in a way so that it's asynchronous, that we don't wait for.
I think this field for greater discussion.
Yeah.
Because there are some things that make this possible to make it asynchronous, but then Spark can like complete before you send this event or before you get positive answers. I mean,
Okay.
Great, thank you. So another one is versioning of the OpenLineage format definition. So we needed to be really confident about what we can support and also communicate it very clearly. And on one hand, we needed to be flexible enough not to block users each time OpenLineage upgrades. But on the other hand, we needed to be strict enough to reject the messages we're unable to handle. And we ended up with an assumption that there will be no breaking changes between major versions and defined a flexible enough API. So if, for example, a new field is introduced, but it's optional, we still don't know how to read it, but also we don't reject the message completely. And as a result, we support OpenLineage 1, major version 1. The next one is the updates per run. So in our mental model, we expected the process, one execution of the process to produce one run. And then we observed that Spark just emits new run events as it executes. And as a result, there was a mismatch between our architecture and the actual input we received. But then we noticed that most of the runs we received don't add incremental information to the run itself, only events. So only, sorry, inputs and outputs. So we still create them every time, but we don't alter the run if nothing actually changed about it. So I'm saying it's mitigated because while we do not overload the database anymore, we still do all the heavy lifting for sending requests, then receiving it, parsing it, processing, etc. And as a result, there is no incremental value of doing all this work. So maybe if it was batched logically and it was some actual information that those run events belong to some execution stage, we could take more advantage of it. There is also one challenge that we still have to tackle. So we know that formally inputs and outputs are incremental, and we can receive them between run events. For example, we have two messages. In the first one, inputs are together with output. So we take the Cartesian product and link them correctly. And for the second one, with the current implementation, we would not be able to find the connection between them. So basically this data is not injected as a result. And that's all for now for challenges. And we also, there are also 2 proposals that are already submitted to OpenLineage GitHub, but we will give them more visibility now. And they are both related to column level lineage, or to be precise, to the facet that describes a particular transformation. So the first one, now this data transformation facet is defined with a transformation type that is a string with 2 expected values. And for some applications, it would make sense to formalize it and introduce different types of masked, basically. And also a subtype to give more precise information. Why it can be important? Let's imagine we have one process that groups by a sensitive data asset, and another one then hashes it. Now, the first one is indirect usage of the data, so for many reasons it can be treated as safe. And the second one, well, we need to know whether hash is, like, whether we can reverse it, whether we can somehow use it, so it can warrant investigation if this information is really sensitive. So it would bring more value to distinguish those 2 cases. The second proposal is also about this transformation type. So now it's defined for all inputs and output for the whole operation. But again, it would make sense to have more granularity and define it separately for each input. Why it can be important? Again, imagine a process that takes some arbitrary input and PII, and then it copies arbitrary input and groups by PII. So again, we can say for some applications it's safe. The second one does vice versa, groups by some arbitrary input and copies PII. Now that is definitely PII leak. So if we then aggregate it and put the same transformation types on it, we basically equalize those 2 situations, while in reality they can be very different and have different impact. And that's all I have for proposals today and for the presentation. So yeah, we've talked about Dataplex lineage, how it works under the hood, and what challenges we faced. And if you have any questions,
question. Are you also capturing the status of the process run, or just lineage run?
We do.
So you don't, like in lineage, you can show what is the current status of the
Yes, we captured it when it started, intermediate, and finished.
So maybe I can add something to the point about those incremental events. And there are, I think, 2 cases for first to have a lot of events for maybe one run, right? And those are streaming data sets, streaming jobs, which we are going to tackle better, I think, soon for Flink and for Spark streaming maybe. So then you can have running events that, for example, can tell you what's the actual status of the job, or maybe what's the progress, or like in Flink, what's the current checkpoint. Basically, if you have a long-running job, then get start event, and then nothing, then like you may wonder, is it really running if it has been 36 hours, right? So we have some ideas around that. And regarding those different data sets and different events, sometimes we can know everything about this at start, right? Let's say we are talking about Spark job, and then we have a logical plan that explains we're reading from this source, writing to this source, and it's great. But then I think Jakub will have, we'll talk about this more. We can have arbitrary code that maybe is instrumentally decided, right? But until we run it, we don't know whether it will like send output anywhere, right? It can run, it can have input data sets, output data sets, but we don't know. So in this case, we just have to execute the code, send additional information that we may get later.
Okay, yeah, I see
That's
how
the
it's.
idea behind this different events and incremental updating state.
Yeah, I see how it can be challenging for working also. Thank you for the comment.
So it's interesting that it works like this for the current implementation. But when you look at the column lineage facet, then there you expect currently inputs and outputs to be received at the same time, right?
But do those two run events on the right share the same run ID?
Yeah.
Yeah.
I think it's just a mismatch from like different mental model on our side and our current lineage doesn't. We will need to follow that. But
I would like to see this case actually, because this is a great action.
Isn't it just assumption on our side that the events are cumulative and pick all the data sets from all the events you have to get the overview? So
I think our assumption is that we want to know exactly which data sets were inputs to which other data sets. So that's why we have this mental model of a link as the atomic unit. But in this case, when we receive events, let's say for a specific run, we receive multiple events with different input outputs. We don't know which input exactly was actually feeding into which output, right? Which is at this, let's say, table level lineage. That's the case in OpenLineage. But for column level, the facet actually makes the assumption that there actually defines the links, right, between input columns and output columns directly and atomically.
In Spark is easy because there's only one output, right? There's only one output node. But for other integrations, you can have multiple outputs and then
Exactly.
So I remember when this assumption came from. So for the storages like Iceberg or Delta, we are able to capture the version of the data set. And there's a kernel case that you can read from the same data set you're writing. And in this case, it makes sense to capture the version of the input data set at the start and of the output data set at the end. And I think that would lead us to this place here, which becomes problem.
You had some comments, Maciek, before about what was the other?
Synchronous, yes.
So
sorry, I'll just find
for
that.
Spark. We are running in like this Spark event loop, right? Our integration runs like that, and it can. We basically are sending some message right somewhere, but we are not sure if we are not being killed, right? Because we are sending something, we don't get an answer. Maybe we're processing message 15 minutes. Who knows what happens, right? Or the message size. If you enable some debug facets, the messages can get really huge. I think we had a case where we serialized the logical one, right, as a debug, and it had like 22 megabytes, and tried to send this to something that tries to parse it, and it can be a problem, right? So we have a concept of transport in OpenLineage client that allows us to specify how exactly we should send the message somewhere, right? And if you like use gRPC in Google, then you can add gRPC transport and then do whatever you want. You will just get called, right, with some init method. You can process it in the background, right? But this way you won't get any confirmation that it has been delivered. And I think if we are working with metadata, it's important to know. But yeah, I think if we want to improve on that, we kind of need some native integration with like Spark, something like we have in Airflow, that maybe guarantees us that like we won't get killed during sending the message. So in general, it's a hard problem. Doing this synchronously gives us some at least guarantee.
Okay, that's interesting.
Are there other
Other
questions?
we see a potential issue on this topic with synchronous systems. I understand correctly, OpenLineage operates only synchronous mode, right?
Kinda, I would say. You can use asynchronous. You can write your own transport and send events asynchronously. But you won't get like a feature that you can wait later on in the process, right? So it's just fire and forget.
If I understand correctly, this synchronous model is where the client sends a request and receives a response whether the request is successful or not.
Yes.
Versus asynchronous client sends a request, receives some idea, and can check later
Yes,
the
that's
status.
that's
And this imputs us a theoretical limit on the basically size of messages of each process. And we need maybe a different model. Like asynchronous model offers some workaround for the size limitation. Synchronous model does. I see a theoretical issue here that cannot easily be overcome. Like any system can fail. You cannot change the picture and say that our system will never fail.
yeah, I agree that we can send too large of a message that way. In practice, this happened only if you turn on some debug and stuff. Basically, I don't know, serialize practically the whole state of that Spark session. And we think that the metadata, right, shouldn't be as large as your data, maybe. I agree that we should probably do some more work on more reliable delivery. But I think this is still like issue that warrants bigger discussion and maybe something that needs to be tighter coupled to the actual system we're integrating with. Because like I said, like Spark event listener doesn't give us a way to like reliably work in every case, right? In case that you have short-lived like Spark job, can get killed and you won't know.
Yeah.
You asked for some- Are there any questions on the from the audience on the call? Were you actually able to follow the discussion over here? Michael? Oh,
Mostly.
mostly, okay.
Okay.
I think we should operationalize this microphone.
Yeah.
Okay, we will use the microphone from now on. That was a miss on our side. Yeah, we'll improve on that. But are there any questions from your end at the moment?
Okay, if there are none, then thank you very much.
Paweł will talk next about the Spark integration and give some updates. When there are questions next, we'll get the microphone going, so you can follow the discussion in the audience. Thank you, Mari. Welcome, Paweł.
Welcome, yes. Hello, welcome everyone. I know Michael Robinson. Are you guys able to see the room, the guys online? So yeah, if not, we can count, but the room is almost full.
I'll turn around the camera, but somehow the camera is...
It's covered by the board.
Oh, we need to throw away the board from the window.
Yeah, damn it.
Let's
wait.
We should leave the
Yeah, so starts being dangerous, but the great thing is that I've never seen such a full room on Lineage Meetup. So it's just Lineage, it's governance. No one's interested in governance that much. At least that was what I was thinking about. So yeah, thank you for coming and for spending a couple of minutes with me on updates on the Spark integration. I'm Paweł. You can find me on GitHub as Paweł Leszczynski, and yeah, I'm software engineer at Getting Data, and I'm super happy to be able for to work for like more than 2 years full-time in open source. And yeah, thank you for getting data for letting me to do so. On the bottom left, you can see the full OpenLineage squad, the pirates, and 2 of them you can find in this room if you want to. Yeah, and of course, Big Lebowski is my favorite movie, so if you want to, you can watch it whenever you want. The agenda for this talk is like 3 months of improvements in Spark integration that happened recently, some big issues that we see ahead of us, and yeah, trying to answer the question, where do we want to go? And of course, feel free to interrupt and ask questions, and if we don't make it with the slides, I'll be even more happy if we had discussion like this. But yeah, this time I will perhaps give microphone to Kuba, and Kuba can handle it and give it to guys talking. So we started the quarter with PR 2103, and within OpenLineage 1.0, we released in our documentation the lifecycle state change graph, which is super shiny. And the assumption here is that we allow a single start event for a run and a single complete abort or fail event. So the start and termination events can only occur once, and it turned out that we do have a duplicate events, especially for some case within Spark SQL. And we still send duplicate events because the events are cumulative, and I believe there's nothing wrong with this, except for column level lineage that Jens mentioned before. But we make sure that the start is sent once and the other event is marked as running. The other interesting PR was to unify the dataset naming within Flink and Spark. I'm not sure if you are aware of this, but I think that streaming job support and within Lineage ecosystem will be pretty hot topic in the next months. And the first step to make it happen was to unify the Flink and Spark names, the data sets, because we do have a pretty big user that use OpenLineage integration for both Spark World and Flink World. And that's the beauty of the cross-platform lineage, that you can see the lineage graph and dependencies between data sets, regardless of technology you use. And yeah, so we moved some logic to classes that are shared among Flink and Spark. We included more Databricks tests. So the integration tests that are run on the Databricks runtime. Actually, in Databricks, it happens oftentimes that we emitted the events that didn't bring any value at all, and they were related to something you click in the UI, like the show namespace, collect limit, and we filtered them. Yeah, in general, I think that within Databricks runtime, we don't want to generate and send the events from actions that do not contain output data sets. It's a big assumption, perhaps can be wrong in some cases, but most often it is like this. If you don't have any output data set, then within the job, then you shouldn't generate events out of it. Support for Spark 3.5. This was easy to be added. At the moment, we didn't have proper versions of Iceberg and Delta. I'm not sure if we added it. I think it has to be upgraded. So the latest Iceberg and Delta versions for Spark 3.5 need to be supported. But the good thing was that our integration tests were passing just when bumping the Spark version. And within CI, we check multiple Spark versions, some recent ones to verify if things are still working. We included support for Databricks runtime 13.3, and it's always interesting to work with proprietary code that you cannot see, and you just see that something goes wrong. Yeah, we get info from users that it's not working, and they're experiencing some no such method exception. And it turned out that although this version of the runtime claims it's using Spark 3.4. I think it's using the Catalyst classes from Spark 3.5, and we can solve such problems, but we can only solve them after they occur currently. So yeah, which actually this is for the new Databricks runtimes, but there are some corner cases and issues that we need to take care of to make sure it is working. Another recent improvement is being able to add the Scala integration test. So I spent a long time this summer tackling with this issue, and the user was pretty sure he's able to reproduce the issue, and he published some codes in GitHub, but the code was not precise. It was like telling what he's doing in Spark. So yeah, we did have PySpark integration tests, and yeah, I was able to repeat all his tests, and it was passing. And it was like an endless discussion, which led to, hey, but we are using Scala. And I thought, for Spark, if you write your Spark in Scala or Python, it's translated to some data frame, dataset, or Spark SQL API. That shouldn't be a difference, I thought. But it turned out that there is a difference if you map your data sets into some Scala case classes, because then you run out of data frame API, you move into RDD API. And in this case, we are missing some support for some node within the plan. So, if you're able to reproduce the problem, it's much easier at this time. So the great thing about this was that we added the Scala integration test with this particular job and make sure it's working. Okay, so these were the small issues. It's always easy to be proud about small issues. And what are the big issues ahead? Yeah, this is something I hope we'll have some short discussion about it. Spark parent application. So currently, OpenLineage event is sent per each Spark action. Up to my understanding, there are here at least two problems. The first one is how to group actions into a single job run. So if I have a Spark application and it reads from many tables and writes to multiple tables, and each such write is called an action. So the action is something that triggers the execution of data processing. Yeah, how do I know that all those actions are contained within a single application? How can I group them? How can I know if the whole application failed, succeeded, or whatever? And I don't know if any one of you has an opinion on that, or at least an opinion on if the problem is stated correctly. I'm looking to Jens because I thought Mary, yeah? Yeah, because in order, I don't want to ask you for the solution because we can try to tackle the solution, but just to make sure that we understand the problem correctly. Are those two bullets?
That looks very similar to my slide with history, so that's what. Yes, that's very similar. Thank you. Yes, that is very similar to what I've been describing a while ago. Yeah. During the presentation.
Do we actually want to show on our side one process per action later or a process per application? Okay.
But one run per execution.
Maciej? What do you think about it?
So I would describe the problem from like Airflow perspective, right? You have a DAG, and in the DAG you have multiple tasks that are running, maybe concurrently, maybe not. And in this case, we have one Spark file that reads data, writes data, right? If you read a data and then write it to two tables, you get two actions, right? And for most people, I think mental model is that their file, or like notebook, is their like job, rather than two multiple jobs per one file. So from OpenLineage perspective, we have a construction that allows us to like group the runs, the jobs. And this is called parent facet. And parent facet allows us for a run to describe like a parent run that spawned this run that we are currently in. So in Airflow, we can think of it like a DAG as a big run that spawns all the tasks inside, right? And for Spark application, we could have something like that, right? What it would be is a further question, right? Because we don't have the explicit knowledge about that, right? If we have an action, we don't know if it's a part of like some larger notebook or something like that. So it's not as well defined as in Airflow, I would say.
Yeah, I'm happy with the confirmation that the definition of problem is the same, because
so we have customers asking they would like to have more explainability on our side of their Spark applications, and by that they mean drilling down in Dataplex into the Spark actions that make up the application. So from our side, it would be useful to have both the application and the actions represented as jobs, and then use the parent run facet, as you said, to link those two together.
I can maybe add one more. I can add you one more thing. I think it's a great case for lineage to be produced by the actual data producers, right? So in Airflow, we have a native integration with Airflow. We kind of have a defined API, and we can like decide that we want to collect this data, shape it in some way. In Spark, we are using the pre-existing interface. That is, I think, very good, but does not allow us to, understand things like that. And native integration with Spark would be very helpful, because we could define, we receive an event that some job is running, and then we could have an additional information that is a part of some notebook. We've actually, I think Paweł and I independently tried to know, like if we are running from some notebook inside this Spark event, is it possible to know that this job is part of some notebook? Or in case of Spark SQL, can we get an original SQL statement that caused this execution? And it seems that it's not possible, or maybe it's possible with some very advanced reflection, but we don't really know where. And yeah, this is another case where I think some native integration will be useful.
yeah, could you handle the microphone too?
I want to say what's my mental model here. Maybe I don't have the full understanding on the Spark details, but in my understanding, we have some template in Dataplex lineage. It's the process, and we have the run, which is the execution of this template. I associate it with like we have an application, give it some parameters. So application is the process. And when you run it with some parameters, you have the run. So run contains those parameters. And ideally, if you have a program, give it the same input, you get the same output, which means if the system like Spark contains the template, like the process, and knows what are the parameters of that process, ideally, you could generate like a fingerprint, a hash, some ID, which could be used as a grouping key. This way, assuming that each run is idempotent, you would have a way of figuring out which events you'll get in the end. I mean, in the end, you want to get events of lineage with input and output. Does it make sense?
I think you've described what we independently did in Airflow, actually, because we also send like two events, start and complete there, and we deterministically generate run ID in both of those from like that parameters. In Spark, we probably could do that, right? Our other idea is to send like a wrapping event that we receive events on application start and application end from Spark listener, and then we could generate those run IDs and store it. But Paweł, for example, really wants the Spark integration to remain stateless because right now we just receive data, extract some things, send an event, rather than like store some things in memory. Like having it stateless has a lot of advantages, like not possibly causing memory leaks. So yeah, there are ways to achieve some wrapping. The question is what's the best, right? And basically, do we want to commit to some model that we don't fully yet understand maybe in doing it this way? I guess this will be discussed and probably resolved soon. Right.
There's a question from Sherry.
Oh, I'm not able to read it. I don't know how to find it.
Sherry, you want to share your question? You want to unmute yourself and ask?
Sure. It wasn't. It was not a question. It was. I mean, I phrased it as a question. It was more like we have that with things like notebooks, but we also have pipelines, right? So it's like a parent object, a parent facet might be a pipeline kind of situation or a stored procedure, right? So this is something that comes up a lot, is to have that hierarchy.
Yeah, exactly. I think we can describe arbitrary hierarchies using this.
Okay. Anyone more would like to give a thank you, Shir? Yeah, it's similar to anyone. Any comment more?
One more question. So have you been thinking about the hierarchy outside of a specific system as well? So Composer calling a Dataproc job, for example, that then triggering some other execution in some other system?
I can.
Yeah.
Yeah, basically it works right now if you set it up. So the same way we have like parameter that you can send in Spark config that describes this parent run ID, and then integration sends it. But for Airflow, it works only if you like set it up manually right now. So if you use like a Dataproc operator or EMR operator or anything, you have to pass your custom Spark config and some Airflow macro. And as we are integrated with Airflow, we can probably add some option that you want this config to be set always, right? Then you don't have to modify your DAGs and it will be automatic. And that's the idea, right? And we could probably generalize it into many other systems. I think it would be great if we could do something like that with SQL-based systems, right? Because our input is only a SQL, and the database could potentially also like share lineage. And there's some like, I think, things you can do with Snowflake right now, but you can't like send an parent run ID and use SQL right now. So in general case, it's also a hard problem, right? And that's also why we are doing this standard, working on something open to be able to maybe potentially in the future have this kind of hierarchies everywhere.
Okay. Yeah, that was just one of three big issues. The other one is perhaps simpler to discuss. It's just at some point we need to support Scala to the 13. Currently we do support Scala to the 12, and Yeah, I think in order to support it, we need to publish 2 artifacts. So yeah, that's some issue that we'll need to tackle. Because I believe that at some point Spark will only support 2.13, and it's going to be more and more users that use the Scala version. And the last slide on this deck is where do we want to go, and kind of the strategic goal. So the problem we do have with OpenLineage Spark integration is that we are suffering from multi-dimensional complexity, because we do have multiple Spark versions and the methods and classes differ slightly per Spark version. We want to support, and we do support, Iceberg and Delta as storage providers, and we also want to support different versions of Iceberg and Delta connectors. And actually, we want to support different versions of any connectors, like or Spark extensions, like the BigQuery or Snowflake. And with such multi-dimensional architecture, this leads to problems and makes it heavier and heavier all the time. And the idea initiated by Julian, even some issue that I don't remember the number, is to, what are we able to move it to other code bases and make it cleaner? And this is the idea I just started working on and would like to work more in the near future. And the general idea is to create some package with just interfaces to be implemented on the Spark extension side, so that we can move the implementation of lineage extraction logic directly to those extensions, and perhaps remove all the dependencies to the third-party extensions. Like, if we're able to generate lineage within Iceberg, in case it is the Iceberg node within the Spark logical plan that's responsible for processing data, that would be a way easier for us. But of course, it's not good to advertise the idea as good for us. I think it also gives great capability, great options, great advantages for those extensions, because those extensions in most cases have really great statistics and insights that would be worth putting into the OpenLineage event. For instance, in case of Iceberg, there's an issue with a list of potential interesting statistics that could be put, like the amount of rows written, committed, and so on. And it's like, dozens of such numbers. And so I think it's like the advantages could be on both sides. On us, it would be, the easier way to produce the lineage, because the logic will be directly within the code that's processing the data, and for those extensions, it will be easier to expose anything you think is interesting to OpenLineage model. Yeah, and perhaps later on we could advertise this approach to Spark community. So I don't know, it can be a long way, but I think it's worth going there and discussing it, give it a try, giving it another try, and come up with some good solution at the end. And this is the last slide here. Do we have any questions? And a silly story, Scuba, I'm looking into.
Not this time.
Not this time. Oh, if not, then thank you very much. And yeah.
Hi, can I have one question from the audience?
Yes, please.
Remote audience. Okay, so I noticed recently a fact that I want to gather the events from OpenLineage for my processing, and I play a little bit with Marquez, but do you have some ready-to-go solution to gather this event, I don't know, back to Iceberg or something like this? Or not yet? Or you don't plan to do it?
What do you mean by back to Iceberg?
So basically, I'm like modifying or processing iceberg tables using Spark, and it will generate some kind of events in OpenLineage. But then I want to see those events possibly in Spark, right? Because at the end of the day, the events amount will be huge. So I want to have some kind of processing engine to filter out events only I'm interested in or something like this. So maybe not the you do it by Marquez, right? But
Yeah, I
I'm more
would
thinking
recommend
about
using Marquez and its REST API to filter, to get the whole lineage events, or to ask for the job data sets wherever you want to.
Okay. I was wondering about like the scale. Do you test the Marquez with the big scale? Like for example, if you have thousands of Spark jobs that reading hundreds of thousands tables, and what will happen then? The REST API seems to be like bottleneck there, but I don't know. Maybe it's worth checking.
Yeah.
Okay, thanks.
Maybe
No,
you
no.
should implement custom transport, send it directly to your database, or have some proxy for that, right? And then query it however you like. OpenLineage client has an option to define custom transport, which allows you to send it wherever you want, right? If you implement the class.
Okay.
Yeah,
And there's an existing transport for Kafka, for example, as well, if you want to send it to Kafka. And Paweł, you built a proxy to send it to multiple destinations. So you can forward to Marquez and to Kafka separately, files, if you want.
We've built a Fluentd proxy that lets you copy the event and send in a location you want. And, you know, it's a Fluentd, so it's a ready out of the box solution. And it allows you to treat OpenLineage events as a casual logs, which can be JSONs as well. And so there's a bunch of Fluentd output. I don't remember if it's processors or output stuff. And one of them was to write it to S3 directly. And I'm pretty sure you can span some SQL on the top of this. But I know that people are having pretty big Marquez instances, but I'm not sure if it's like millions or 100,000 of events. Yeah.
You can definitely put millions and then even tens of millions of events. Right?
Yeah.
So Marquez is backed by a Postgres database, and you can send a lot of events to it before. And Marquez has an option to expire all logs as well.
Okay, cool. So great info. And about this forwarding events to Kafka, it's like already in this version 1.5, or do you mean like we can write the custom one on our own?
You mean like OpenLineage Spark integration? Then the Kafka is for more than a year as a transport option.
Okay, cool. Thanks, then.
Thank you. Great question. Wow.
Thank you so much. See you then.